Okay, ich hoffe, es stört euch nicht, wenn ich mit nebenbei noch ein bisschen Mittag esse.
Machen wir Englisch oder Deutsch?
Yeah, okay. English? Yeah, okay. So, that was announced in English, so we held it in English. I hope you don't mind if I have my lunch while I'm talking. This workshop is about the state of various projects in telephony voice encryption that are underway in the family and its surrounding, and we're trying to get an overview on how difficult it is to build up devices for telephony voice encryption, or how easy it is, what different approaches have been taken to get to this goal of having a secure and comfortably encrypted telephony signal by using a device, not a PC. There are several projects right now on the net that have done that by using simply a PC and the software and doing an encoding on it, encrypting it, and getting it out. If I look at the number of software-based voice encryption systems, I see that there is a strong demand for such a system because the competition gets more heavy in the economy, and people tend to talk a lot about the telephone. So it's far more secure to have something that cannot be surveillanced, both for your private communication and the communication of the company. So that is something that will have an increased demand, especially after the publications on the Echelon system from the NSA that do some more like an Hoover-like approach to the telephony surveillance. It seems to be necessary to have secure voice encryption. You can achieve different levels of security, from technical security that is only secure for some hours if someone is after you, to real security where you need to apply really heavy measures to get to your goal of having secure encryption. I think we will cover some aspects of this in this talk. We have today here to my left the current Chaos project on telephony voice encryption, and to my right is Lucky Green, who will hopefully tell us something about the current status of the Starium project, which is a project that is emanating from the cypherpunks corner of the net. Yeah. So maybe we start with the Starium project and then go over to the Chaos project. Yeah. Okay.
Good morning, folks. I'm Lucky Green. How are you all doing this morning? Everybody awake? Who didn't get a shower this morning? Raise your hand. Okay. All right, about 30%, huh? Anyway, let me first say that I don't work for Starium. I absolutely have no connection with the company other than the fact that the owner is a personal friend of mine, a longtime cypherpunk, and that I'm a very satisfied customer. But I don't get any money for saying good things about them, nor do I believe Eric Blossom would be too happy if I said bad things about his product. But I actually like it. Starium is a company that is located in Monterey, California. It's just south of Silicon Valley. They have the company used to be called what used to be called ComSec. I think used to be called Communication Security Corporation, ComSec. They have a box that is the form factor of a standard external modem. It contains a it contains a GSM codec and a hardware random number generator, triple desencryption engine. Unfortunately it requires only a 14.4 modem, but unfortunately the modems talk sync, which means that they have to talk sync. Otherwise, you can't fit a GSM data stream into a 14.4 modem. The only way to make that happen is for the modems to talk sync. It doesn't work in async. So unfortunately, software emulation is somewhat challenging. I've used this device now for a number of years, and I must say I'm quite impressed with it. Sound quality is excellent. I frequently use it for international phone calls. I use it for phone calls to Europe. I use it for phone calls to Japan. And the voice quality actually is in many cases better than the voice quality of the existing line. So that's certainly, I'm serious. It's quite amazing. It's quite amazing. Even though nowadays most phone calls run on fiber, international calls certainly, but the voice quality is actually better in many cases. Anyhow, I meant to bring one of those boxes. In fact, I meant to bring two of those boxes, but I forgot mine, and I guess the other person that was supposed to bring the other forgot his, so I can't show them to you. Starium, Eric Blossom had been making these boxes now for a number of years, but never really greatly commercialized on it. I doubt he sold more than 500 of them. They have a company now. Once the company was renamed to Starium, and received some funding. They're now building a device about the size of a Palm Pilot, actually not quite, smaller than a Palm Pilot, that is the next generation of their voice encryption device. It looks pretty slick. I've seen some early designs. It's actually designed by the packaging is designed by the same person that designed the Palm 5. So if you guys have seen that, it will be a really nice finish, steel brushed finish. And now the good news is that it will be under $100. Currently, these boxes cost $750 each. So you need to spend at least 2 times $750, but you'll be able to do that for under $100 once they actually go commercial. They also are talking currently with a number of cell phone vendors to actually include these devices in their phones, and have made some serious progress there, much to my surprise, I must confess. When will it ship? Oh yeah, it's... Yes, they will ship to Europe. Basically, what Eric will do is a very similar plan as PGP has done, namely to export the design documents and source code in paper form, which of course is exportable from the US. These things will be mass produced in Hong Kong and Taiwan. So yes, they will be available worldwide. Let's see, what else is there to say? When are they supposed to ship? Well, they were supposed to ship long ago. The new ship date, I think, for the first alphas is sometime fourth quarter of this year. It's a pretty nifty device. If you ever get a chance to try one out, do so. It will not be open source, I'm afraid, but I'm not sure whether. Well, it's a hardware design. They're using custom chips, so yes, you can make it open source, of course, but no, it won't be open source. Sorry, guys. Still cool though. However, we do have an open source solution here, and Hako, right? Do I remember correctly?
Yeah.
I met this guy at the CCC Congress. Hako here, however, has an open source solution, and probably
we're presenting
more about it.
Sorry. You're about to tell about Trump's project? Later. Yeah.
Okay, I got it. Sorry, I'm so hungry. Our friend Tron, that is now not anymore with us on the Earth, has it an own project on ISDN voice encryption. That was in fact his doctorate Diplomarbeit, and he did a complete hardware design based on DSPs. Where he used an external analog digital analog chip and DSP to do the encryption and ISDN line interface. So it's an ISDN only device. And the problem that he had was that his colleague that wanted to do all the key handling stuff and all the ISDN low-level stuff had a heavy disease, so that he couldn't do his part. So Tron was forced to do everything himself. That ended in there that he did the whole ISDN stuff, all the D-channel protocol in assembler. I've never heard of anything that crazy.
No, the old telephone PABXs were programmed in assembler completely.
Yeah, okay, but that's long ago.
Also the D-channel.
Okay. And so the telephone, everything about this phone is published as his work on our server, but so far the projects to take this thing further were not that successful, because the software that he left behind was not that very well documented. In fact, it was not documented at all. So that's nearly impossible for anyone to understand the software without putting in the same effort than it would require to do the whole stuff again. he has the general and main problems that he has solved, and the way that he has them solved are described in his text. So that might be an valid point to start, but what we found was that it's extremely difficult to do such a project and convince someone to continue someone else's work that is not very well documented. So this project, I think one guy is trying to bring it forward in the context of his university workings, but at this time I must admit that this project is nearly dead, and so I don't think that it will be continued. If someone proves me that I'm wrong, I would be very, very happy, but at this time it doesn't look like it is. Okay, now Hako or Ingo will introduce the analog chaos telephony voice encryption project and what they did. Yeah.
Yeah, so we had the same idea of the need of have private communication from point to point, and started up to do the design, or still have an idea. Like we have a phone, a regular phone line, not ISDN, analog line, and we will have the same thing on the other side. So we need a device which will do the encryption, and in a way we can securely say it is an encryption, or it can be verified or modified by anyone who wants or who understands about the software encryption and so on. So what we wanted was a standalone device which don't need a computer or anything else. Also, yeah, like a box in whatever size, and have it connected to the telephone and the telephone line. We will have the telephone on one side, we will have the box, harmless little box named in the middle, and the phone line to the other side. So if you start a connection, it is just like you respond a regular phone call. You will pick up the phone. If you want to have the line secured, you will just put a button to activate the device, so it will establish a connection to the other side via modem, which means there will be a modem connected to the harmless little box. At that point there will be a handshaking. The voice will get digitized by analog to digital. There will be a voice compression by GSM algorithm, and it will be encrypted and get to the other side. So we can handle whatever algorithms on encryption. And by the way, we wanted to have it in open source, which means in any point, if somebody else wants to verify this or have another idea or want changes, he will be able to do so. Everything on this phone will be free. It will be released, the board, the software, and so on. Just the only thing is that commercial use is prohibited. Yeah. This is the point. So that was the idea. Any question at this point? So far, no. So yeah. So we will just show what our progress is right now. We had some development over about 3.5 years. There have been different microcontrollers which with different capability of processing. And yeah, right now we have design we will present right now.
Okay. What we have right now after a long-term development process is this board. Sorry. Yeah, it's only beta, so we are going to change that. The current design consists of Hitachi Super Hay RISC CPU, and that is this CPU you will find in handhelds Windows CE like Cassiopeia. So it's a normal CPU. It runs this version runs about 80 megahertz, and we think that 120 megahertz version will be the final version. And so it does everything in software. We don't use any DSP. You don't have to hassle any DSP code if you want to program something on the box. And Yeah, the basic design is just the CPU, RAM, ROM, and a serial interface. We have two of them. An analog digital converter, that's the most common from TI. You will find it in every US robotics modem. So it's really easy to build that box. The only, at this point, specialized device is the line interface. But the line interface can be changed by discrete logic implementations, but then the box will be a little bit greater. And yeah, that's the hardware.
So what we are doing with this, what we are doing with the calculation power, we got a lot of them. Yeah.
What do you mean?
So what we need this calculation power for is mainly the encoding of GSM. Like we need a lot of compression, like to have regular voice, and like we use it on GSM phones to get it over the phone line. On ISDN we don't have the problem because we had a lot of bandwidth of 64 kilobit per second, and if we want to have an analog device, we will use a regular modem, which means we will go down to 14.4 or 19.200 bits per second over the line, not synchronous, asynchronous.
Yeah.
And so yeah, that's the main point. We need the calculating power for. Encryption don't need that much calculating power. But that's what why we use the processor and so on.
Yeah, we don't provide the modem on the board. That's your choice. You can hook up an ISDN TA or an analog modem to the box. That is for communication. So there's no hassle in with FCC regulations. If you bring that box to another country, you must confess that this modem is FCC compliant. To just buy a modem in your country where you are and hook it to the box.
And at this point of view, if somebody has an old modem no longer in use, it will still be enough for the device to use for the encryption. Because I don't know who has a 14.4 modem and is not using it anymore. So it will be some around, or it will be really cheap to get.
Don't throw it away.
Yes, don't throw it away. Okay, so yeah.
Yeah.
So just presenting what we are doing right now is we have the GSM decoder and encoder running, and so the sound you will hear is coming from the ROM right now because we don't have two devices in the phone line here, but mainly we will present you a calculating power of the protocols and algorithms we are using.
Phone. Tut nicht.
Beta.
Just checked 2 minutes ago.
Hello.
Oh no. What's going on? Okay, that was Neil Armstrong, because this sound is not copyrighted. On the software side, we use at current a normal GNU compiler for the C software, and for the assembler part also, because you can cross-compile that package perhaps under Linux and build code for the machine. The other software parts that are ported to the machine is the newlib, because this library is reentrant and it utilizes functions like malloc, printf, and stuff you always need. The next part is we are using the GNU multi-position library. So you need a big num library to do things like LSA, encryption, Elgamal, Diffie-Hellman, and this stuff. And perhaps you can do it in assembler, but I won't recommend that. So if you have just a big num library, porting ASA to it is just take you 2 hours and then it will run. And it's very easy. They did a great job. It was easy for me. Yeah, the part of what you will, how you will encrypt the data is the part of what security do you need, which means, of course, we can provide open key exchange systems, but if you, for instance, choose ASA, you must take care that your private key is never published outside. So I won't recommend storing your private key onto the box, and because somebody can tamper that box if he has access to it. So if you're choosing systems like ASA, you must we probably will provide a smart card interface, and then you will have to store it on a smart card and take it away if you are not communicating with the box. Yeah. For the other systems like Diffie-Hellman and Elgamal, this is not required to have keys stored on the box because they are generated on demand. And as I now see an exchange and a calculation of 2084-bit key will take up to 15 seconds to exchange. So you have to wait until this key is exchanged and calculated, and then you can communicate, and then you have then you must take care that the key you have exchanged for symmetric key exchange is another secure communication way. So what we will provide is triple dash, 2FISH, and the stronger ones for communication or IDEA, but IDEA is more a problem because licensing, if you put it on commercial, perhaps is not permitted, and we will see if what key system you choose is more a user option, because the box comes with the software, and if you are in fear that the key length is not big enough, you can change it and just calculate with bigger keys, and then you will see if it's working or if it's working not. The most problem is the software GSM decoding, which now utilizes about 50% of the CPU. So the other 10% will be the I/O communication, and so you have 40% of the CPU for doing crypto things. What is that?
Just show you. Here is how this device can be connected, just for the future purpose that we are talking about.
Yeah.
So you will have a tiny little box which will be connected to the phone and to the modem. There will be a switch, which means like the phone length is the same line for the telephone will enter as HLP. But the HLP, the back box is not activated. The line will go in and go out to the modem and go out to the line. That means if the modem is not in use, the box is not in use, you can use your telephone like you're using it regularly. So if you want to activate the HLD, which is a red button, a big red button or whatever, it means the modem gets activated. The line is no longer connected to the telephone, but on the same second, the HLB will switch to provide support for the telephone, which means you can use your telephone and the voice will get in and out to the telephone you're using regularly. Just as the voice will get digitalized.
Converted.
And will get encrypted and compromised to go through the modem to the telephone line. This is the idea about how the box will work and how it will be transported and connected everywhere where you have a modem. If you want to have a more luxurious version, you will still connect to the modem once again the telephone via the HTTP, which can switch between the phone line directly, will connect these two directly, or if it goes through the HTTP to the modem, to the line.
One major concern in the electronics design is that the guys try to prevent leaking of the analog signal into the digital encoded signal on the telephone line, because that's one of the major forms of attack against voice encryption devices, is that you look for traces of the analog signal that's going into the device on the outgoing phone line. So that is one thing that needs additional measures. But one thing about security level, that this device, of course, does not protect you against a bug in your flat. If you're bugged, this will not help you. This is only the aim of such a project is only to prevent your telephone conversations getting into this NSA Hoover echelon and being sucked up and analyzed. And that is the only real purpose of that project. And how much security you achieve with this system is not so much a question of the length of the key that you're using, but very much more a question of the procedures you're using when telephoning is secure. So you need to verify with whom you are communicating. You need to verify that the telephone that you are using is not bugged. You need to verify that your room is not bugged. So that is a very much more concerning problem there.
Yeah, the other point is why we are using free software. So the point is that this software can run on a PC also. You have to change just the low-level drivers and for serial and audio communication, and then this software might run on a Linux or Windows or Macintosh also. So you don't have to reinvent the wheel another time, and but that's not our point. So perhaps if people like that project, they will find a way porting it to other platforms.
So once again, for security, this is an attack on the lines. This will have to device again. You cannot go drive to the phone line, but that's the phone information and so on. But we're going a bit farther, like encryption. The point is if they are back in your room, whatever, this cannot help. So we also choose some security, like there will be ways to compromise the software. There will be.
There is a certain problem if the device is not properly shielded, that there might be a possibility to guess the state of the encryption engine by using tempest emanation. That means the emanations that are from the CPU, the HF is generated there. And so building such a device besides is not only a difficult problem in terms of building up the electronic, getting the CPU to work, bringing the compressor to work, and bringing the encryption engine to work and stick it all together, but also in terms of building a proper enclosure for it, looking for the line interface that doesn't leak. So that's not an easy task of doing.
Yeah.
Using the light interface and the box provides this order to inject noise into digital line, which leads to the modem, and turns out
The real data that is needs to be protected is going through the modem in digital form, and so what can be done is that the electronics is built in a way that you block the digital signal galvanically from the rest of the electronics. So that.
Line interface of the arm is with the phones. The upper one. No. This one.
This line, or
This line.
outline.
This,
Look at the phone line and the line connected to the Hammersmith box.
This line.
This line.
Connected, right? Yes.
Look at disconnected by the Hammersmith box. So the telephone is not physically not connected to the line anymore. The second way, telephones like one in Europe, the line connected the second
In
line.
those days, he just wants to insert noise there so that it may slow out any analog noise going over to the line. Because the speech is going to go either over the serial link or over that analog phone wire coming from harmless in the box. If you insert noise on both points, you have a point of there's a chance of drowning out the signal. It's just that you need a lot of noise and you can still statistically cancel it out.
But it's noise on this line connected to the Hammersmith box.
Yes.
Verstehe das nicht.
Er meinte, das digitale Signal oder die analoge Sprache überkoppelt auf diese Leitung und dann normalerweise die Brücke nach draußen, das ist also die normale Serial-Modem-Verbindung, dass da halt wirklich sprichst, irgendwie das Zeug wieder nicht rausstrahlt.
Yeah, why not?
I missed the first 20 minutes. What's the status of the project?
We are working better over here. It's not looking very nice, but that's not making out for GSM encryption development.
The status is that we have done all the low-level stuff. Which means we are now at the point where we think about what should be in the software, how does the device communicate over the serial line, and the next point that is a parallel point is to build up a final hardware, because this is only beta, so it will take up nearly half a year to make it market ripe, perhaps.
So the next communication congress in December, we will have it ready.
Timetables set by technicians or project managers?
You know, if
I'm a technician.
Okay, if I would be the project manager, it would be ready to the Congress. But the problem is that it will be ready at the Congress. I heard this now 2 or 3 times. So okay, so let's see at the Congress what's happened. So.
What's the exchange going to be? Are you still doing chip diagrams or?
The point is, if you are doing key exchange, you can use Elgamal and Diffie-Hellman without storing any keys or anything onto the device. If you're going to use RSA, you must provide a smart card interface to store your private key onto the smart card, and I recommend the cheapest way will be the German Krankenkassenkarte, because it utilizes about 4K of memory after your address. Insurance cards so you can hide your key on any card, but this is not the point. Is you have to choose your public key system. If you're satisfied using Elgamal and Diffie-Hellman, it works for you.
Okay, so let me get a step further. What we also have built in this device. So separate
But
from the first.
I can show you how it calculates if this pylon doesn't get stopped by the serial communication.
So we will also have a second serial connector, which we have one for the modem. We can probably will connect the modem to, but we have a second. too. So the idea about it is there will be a new way which we can use a device for. We still will have the telephone. We still have the harmless little box. We have the modem over here. This is the line. And what we can connect here is, for example, a PC. The idea about this, we can now do also monitoring of keys or whatsoever to exchange with HLD while it is running. Or we will have some software which is not written yet. We can also send messages in the spare time when there is no conversation on the line. It can also be shown on the display directly, which means on the other side there will only be an HLD to display a message or whatever, like a smart chat in written form without talking.
Isn't that a bit of a 1980s solution? If you have PCs on both ends, why not do the speech on the PC and just use IP and have all the encryption of IPsec or...
Because of software tampering? I think
If you don't do key management or anything on the PC is...
That's only one option.
This is an option. We still want to have a single device which can be used without a PC. And we just have the box encrypted conversation.
You can also use it as encryption for fax systems, because you have connected a modem, you have the HLB in between communicating with your PC, so you can do any type of encryption or this alike. It can be as transparent as a modem looking on your PC side.
Or you can use a Palm Pilot as a storage device for key stuff, or you can even choose to use a Palm Pilot to communicate or check your mail, whatever over the system. Yeah, that's the idea behind it.
Das ist eine Frage.
Yeah.
So,
So we also have a way a computer which will be connected to like a BBS or whatever, and most better way without IP. Will be able to, without the telephone, without using it at this point of usage, the modem can get, also the line data can get encrypted and transparently automated to the PC, which means there will be a way of securely have the data conversion to the regular modem over the HLD to the serial part of the PC without knowing any software running on the PC. There's no custom software necessary at this point. Like, for example, you can run a BBS or whatever, it will just be able to reach through an HLD on the other side. It is configured like this just to accept calls with an HLD on the other side. Which means you can have a notebook, you will have an HLD, there will be an HLD and a PC at your home, which will answer all calls, and there will be the software, your personal mailbox, your remote access or whatever. It will be encrypted, it is secure, that you and only you with the right key for your HLD will be able to connect there and exchange the data. So also you can use it for other software like PCN, I don't know, for remote access and remote customer service, which we don't know if it's secure or not totally, because this way the data which get transmitted will get encrypted, and calls answered by the PC with the software can just get answered. There's a HTTP with the right code on the other side. Okay, so there's one more way. So the PC will send the information will get encrypted and the other way without telephone. We're talking about it right here. There's one more way, and like if the modem is not connected to the HLD, it might not be here on the PC. Can be IP or whatever other protocol to get to the other side. So at this point, you can also use a telephone once again to run through the HLD through the PC with the software to go to the modem.
That's a waste of space. Yeah, please add a sound card and then do it also on the PC.
On this way, you can also do it over TCP/IP. on that end, but also doing a lot of calculating power, which well, all the PC are not capable of. Your PC
Why not put a little screen and a keyboard on the HLB and an Ethernet port?
Good point. Did you ever port an IP stack to just basic raw device?
Why not just call it a notebook?
No. Okay, we were thinking about, at the present time, we know two solutions that can handle it. One point is porting Linux to the HLB, which is possible, requires a little more flash RAM because Linux utilizes about 1 meg of flash RAM. And the current RAM configuration is no less than 4 megabytes. That's crazy. We never ever use 4 megabytes of RAM, but it's the lowest SD RAM we can get. If you think that IP is a solution for everything, you can port either Linux but this is just too great. Imagine you have a whole system, and the software you are running for secure communication is that low, and so you have to look if nobody has tampered your Linux implementation with something. You have to check that. If as far as the software is as close to the machine and is very small, you can control it. You can see what does this software.
The same goes for the solution with using IP through the PC to the hardware of the box. Because then you just write
Nah, this is not the normal way of using it, but
you write the backdoor of this plugin for HLB.
not for the no. But the other way is real-time executives like AirTerms, which comes with an IP stack, but I won't recommend it because kann man das mal abstellen? Fürchterlich. Because you don't need it if two devices are talking together. You only need it if your box is only connected to the internet. And that gives you more pressure about latency on the internet, and it's not really good for direct communication. Is that the point? Okay.
I think really one of the major advantages of this design is that you concentrate all the security onto a very small amount of hard and software which you can control very easily. So this is, I think, really the advantage. You can look into the hardware design, see every gate, and you can trace down the software with your debugger and verify that there's nothing wrong going on. So it's just a part which you can plug into rather complex systems to handle the security, and the device itself is quite independent, and it's rather difficult to modify it from something outside. We paid attention to that. So
What's the status of the software and hardware? Is it freely available for commercial use?
No, it is not available for commercial use yet, or at least we need to think about this first, under what license it will be possible. This is an open source project, but no commercial use or not yet. We think about it to get it distributed. There's not this problem, but since we are developing it, we want to have a bit of control, like to see how it gets used and where to get it and so on.
And we don't want a marketing department that putting pressure on us.
And on the other way, so
And getting around bad designs very early.
Make sure it's free for commercial use. Somebody else might market the pressure.
Yeah, and he is making big money by getting our device working. Not only working, just to manufacture. What we want is, if it is free to use, if you build boxes, it's okay, but if you make money with this, I'm talking about selling it with more than what you have to pay for manufacturing the box, it's not okay. We want, what we want is to give back something, and of course we have spent a lot of money to get it working, and yeah, buy an oscilloscope and you will see what it costs.
So it's just also we want to have it distributed. If there's use it for it, if somebody wants to use it, he can build it himself, herself. On the other hand, if there's commercial use, there might be, if somebody make a bit of money when selling this and doing service in this, okay, but on the other hand we want to have the ready-built PCBs with a processor on it, which is not easy to solder on it, ready to give it to end users.
I think
we'll discuss that, but first let us finish.
These guys are really paranoid about marketing, so let them finish and then we market it.
Just like we discussed earlier.
Yeah. First get ready and then get the sales droid to sell that stuff.
Okay, do you want to talk a little bit about randomness?
Any questions?
Yes, random.
You have basically two ways. One way is that you have a shared private secret key with the other user, so you won't have to use any public key system. And if you don't have that, you have to use a public key system, which what will come with the box will be ASA and Diffie-Hellman respect to El-Gamal. So this is not a problem. There are more problems like man-in-the-middle attacks, where your key can be altered. So you have, if you using these key systems, you have to verify that the other side is really the other side. So you can do that by just transmitting a hash key. So both sides independently generate, verify the hash, and if you start to communicate, you tell the other side the hash key over the secure line, and if it matches, you're on the secure side because your key is not going to be altered through the hash key. So this is.
Can I rephrase that? Diffie-Hellman is a really cool way for two people to securely establish a secret that only they know.
Dann Beamer gibt's uns.
I think what hasn't been said here is that the Diffie-Hellman method, Diffie-Hellman algorithm, is a really cool way to establish a secret which only two people know, even though they have no prior exchange secrets or exchange public keys or anything. The only thing is that you know that you have done this secure communication with a party, but you don't know if it's really the other end or somebody in the middle. So if you make a short version of that key and read it to the other person, then the other person that knows your voice can then verify that you have the same hash as the other side. So any man in the middle would then have to intercept be the man in the middle, arrange for two different keys, because each party could verify that his own randomness was used in that key, would have to intercept both channels, and would then have to wait for you to read that hash, have somebody there with your voice or some machine with your voice, and then instantly insert the other hash that you're not reading, and then have the conversation go back to normal, which is still possible, but it's a drag. And it's not something they can afford or easily do for millions of communications all at the same time.
So in an automated way of man-in-the-middle attack on modem, on serial data conversation, it might be possible to do a man-in-the-middle attack on human interface with voice. It is, well,
yeah.
it's
but
a different thing.
It is a form of biometric authentication because it uses the voice.
But you can also do things like let your private key sign and look if the sign authority matches on the other side. But I won't recommend that, because that uses, you probably won't have to sign your keys. But that's for if you're doing it always automatically and you don't want to read any hash keys.
Can you use the microphone, please?
Oh, thank you. So if the other person has the access to the hash key, then why wouldn't he or she have access to you reading the real key?
Pardon?
The other person does not have access to the key that you've transmitted to the other party if it was really the other party you're talking to. Two parties can establish a key and establish that their randomness went into it and the randomness of some other party, and one only, went into it. So they can establish that only you and some party out there know a secret, and that the secret is based on what you supplied. And then the only thing left is a man-in-the-middle attack, but then you wouldn't have the same secrets on each hop. Because you can verify that your randomness is used and only one other. The other party can verify that his or her randomness is used. So the man-in-the-middle would have to establish two different secrets to each end. And you could verify that you have different secrets by just reading them, or a hash of them.
Okay.
Okay, there's another option if you're working with people you know. You can share a key by giving it to them. So this is really quite secure. You can basically use your Krankenkassenkarte, the card if you're ill here in Germany. It has some kilobytes, we talked about it already, and fill it up with random data and use it as a one-time pad. So then there are no real key exchange problems, but you have to meet the people before. This is one of the reasons.
That's not a key exchange problem?
No, not really.
Yeah, that's a different key exchange problem.
Okay. This is one of the reasons why our device has the ability to use hardware random. We've built a prototype of a hardware random generator here. It's just a Zener diode making some white noise, which we digitize and make some numbers out of it. You don't have to do that. You need some random data for public key stuff too. And so this is a user option, I think, but in my opinion, it makes sense.
Now, how can it be a user option if the device does Diffie-Hellman? Because the device is not going to do Diffie-Hellman if it doesn't have any randomness.
There are other sources of randomness you could use. However, they are not really that good.
Yeah, so it shouldn't be a user option.
The problem is that
also,
it's a cost problem, mostly because tuning that hardware randomness device in the production line is not that easy, and you need to shield it so that you have no outside edge of interference. Because if you can interference with it,
you can swamp it.
Yes, you can swamp it. Yeah. So usually the randomness is generated like in def random under Linux. So, but even def random is not really random.
And you don't know who owns your Linux.
Yes. Yeah.
They could just make a symlink dev random to dev null, or
Yeah, but you need random for the communication with Diffie-Hellman because you have to choose a known random, and if this could be tampered for your
I know.
communication.
So the box should, in my mind, if it's a voice encryption box, it should include the random hardware and forget about all the chip cards and second serial ports and all that. Because that's what I want. I want a voice encryption box that I can give to people which they can understand. No Krankenkasse cards, no PC interfaces, just something where they read the 6 digits or 8 digits and they know it's secure and they press the button and it has a green and a red light.
We have to customize that for you.
So at this point we are talking about random.
Forget about the chip cards and insert the random generator, because that's what people need.
So if we are talking about random, we have still regular ways to get a random key, like we measure as a key prints, as a duration and a delay on 2 random key prints directly to the device. This is a regular way we get it, and we can calculate from this to have a regular random key. On the other side, if you're really paranoid to get spied on this, we have a pin on the CPU to support a hardware serial, hardware random input. You can build a device, you can get a PCB for it or whatsoever. Even if it is get compromised, if it is able to measure, if it is not working at all, for example, it will get verified by the device, like statistics, if there's enough yes and no to get a real random or something like it. If not, it will not accept it from this pin. But this is also, the device will get bigger just for the random, which is just a very small bit in relation to the key presses, for example, to get this random. Random hardware is like, well...
But I think it's a good point. Our device should be very simple. We started by thinking we would have just a box to plug into your phone line and a big red button. That should be all. That was what we started with.
Stick with that. You can. It only needs 8 digits. And that's about it.
But as you see the VP1 device, it says it's key over the LCD display. We think that we probably won't need an LCD display because we can read you the key over the line interface and say your key is, and then you can communicate. So perhaps you can some parts of the telephone are just optional, but this is let's call it, this would be an SGK, and we will see what the really needs of the users are, and probably then customize the things that the people need.
I'd like to point out that we have a very nice user interface by using a standard telephone, and we are not able to do that now, but I think we might do that in the future to decode the DTMF tones. So you will not need a display, as he said before, and you don't need a keypad. You just have the phone line as the user interface.
But okay. That's just software.
There was a question.
Yeah. The biggest issue in manufacturing this device will be making the PCB. So if you know somebody who is giving you away, I think a 2-layer PCB on a Eurocard, which is 10 centimeters to 16 centimeters. That's, I think the size won't shrink. It will cost about 500 Deutschmarks at the to manufacture one single box. If, as I said, the hardest part is the cost intensive is the PCB. The PCB in this costs about the half of this board, what's on the board. So you can go down to perhaps 300 Deutschmarks. But then you have to make certain 10 boxes or so. A single box will cost you 500 Deutschmarks.
I think there will be some sort of do-it-yourself
Cool.
kit, do-it-yourself kit available that has the nasty parts soldered on there. There are 2 chips on it or 3 chips on it now that are really nasty to solder by hand because the pins are very near, and so I also think that we will find a way to sell this hardware in a politically correct way. And in a way that the people who developed it get the benefit from it. So expect to have it below the 500 Deutschmark range, which I think is a very good price for voice encryption device in comparison to 2,500, which is the nearest competition from Siemens or Deutsche Telekom for one device.
But they are utilizing only ISDN, I think.
Yeah, these devices only utilizing ISDN and.
But at least they have a back door.
Yeah.
At least they have a back door.
You don't know. You don't know. You don't have the source. You can't look on it.
The interesting,
You know.
the interesting part about this, I should say something about commercial stuff. Yeah, that is necessary. In Germany, there are currently 2 main brands of telephony voice encryption systems. One is made by Siemens, and another one is made by Deutsche Telekom. They are not manufacturing them by themselves, but marketing
Really?
it. Yes, that's
On their own? Not invented by a company?
it's branded Deutsche Telekom, and as far as I can say, the Telesec part, also they're using the Telesec infrastructure, which is a chip card system that has an RSA coprocessor on it, and they're using the RSA coprocessor to generate the session key and that stuff, and have the secret keys safely in this card. The problem with that system is that currently you need to get your card with your secret key from the Deutsche Telekom, who of course promises not to store the secret key away. But there's one project currently underway to emulate this card so that you can simply buy such a box from Deutsche Telekom and get a general purpose microprocessor smart card. And okay, it might be a little bit slower, the key generation phase, but that's not a real problem. And the only problem is that it costs 2,000 Deutschmarks, and you're still not able to say if they are leaking clear text or keys in the ciphertext because of the hardware design. Most of the people concerned with this thing are thinking that the hardware itself is secure, but the backdoor is that they store away the secret keys, but you never know that. So that is an option that might be available in 1 or 2 months, that you go to a general purpose smart card vendor, like for instance Site Control, buy a big smart card that is normally for your for general purpose smart card processor stuff, load up in software from the internet and store your own secret key there. But that's an expensive option, so 2,000 Deutschmarks for one site is not that cheap. The original Siemens cryptophone stuff is even more expensive and is even more insecure because they not only have that same thing that they give you the cards with the secret key, but there are also rumors that on this system there is audio clear text leaked on the line, so that is not a real option if you really want to have security. I was unfortunately not able to get 2 of these telecom boxes. I asked them very intensely to give me 2 of them so that we could take them apart in the re-engineering tent, but they have only 5 or 6 currently, and they don't want to give me 1/3 of their whole stock.
No big market share.
Yeah, they're beginning marketing these boxes on 1st of September actively. There was one small test that did only test the comfort in the CT magazine last week, I think. Yeah. And up on this test, I tried to get these boxes, but it was not possible, at least not for me and for this camp. So maybe I think we will have them at the Congress, and I think we will have the guy who developed the boxes at the Congress so that he can prove that he has no backdoors in there. and I sent him an email, and he said, okay, he might be interested to come. Then I sent him an email back and said, okay, we want you to have the source code listing of your telephone on the stage, explaining you every little line why it is there. And I have no answer yet. Let's see. Okay. There are other commercial voice telephony systems that are around. The most knowledgeable one are the STU-free units. That is the commercial and NSA-sponsored secure telephone units that are American government issue. These boxes also have an NSA backdoor because the NSA, of course, wants to read the telephone conversations of the employees of the U.S. government. And there are some telephony encryption devices around it. I better shouldn't call it encryption, because what they simply do is doing analog encryption. That means splitting up the voice band into frequency channel slots, and then flipping around the frequency so that what you get out is some and they're also doing
just scrambling.
Yeah, and they're doing it also in the time slot system. That's very similar to what you sometimes hear on the police radio. What they're using, that's a very encrypt system. And there are also voice encryption systems that are using such technology out there for telephony. They are mostly sold at these spy shops. So if you want to buy any encryption device, don't went to a spy shop, because they're selling the crap from the 70s as the newest technology for several thousand Deutschmarks. So that is no real option. So yeah. So you always need to determine what the security level is that you need. If you need only technical security about some private investigator, it's okay to use some unit from Deutsche Telekom or Siemens. If you need something that is hardened against the real guys that might go behind you because you're doing some really interesting stuff, then it might be not appropriate to use some stuff from a company that is mostly sponsored by the government, like Siemens. But otherwise, if you're doing such interesting stuff, you shouldn't use the telephone at all. So, okay. Okay.
So what is with crypto AG?
Crypto AG is
just mention it.
Yeah, it's an insider joke. Crypto AG is a company from Switzerland that is only located in Switzerland, but it's mostly owned by the Bundesrepublik Deutschland, and through an holding that is run by lawyers, and these lawyers are also the lawyers of the Swiss Siemens corporation. So that is they have several layers of obfuscation in there, but you can get it that it's owned by the Bundesrepublik Deutschland. This company was founded by Bruno Hagelin, which was one of the crypto gurus before and after the Second World War, who also did a lot of stuff on Enigma-like systems. And this company was approached after the war, really, I think when Bruno Hagelin was in America, by the NSA, or it was not the NSA, then it was Office for Signal Affairs, I think. And they concluded that Crypto AG will help the NSA to break the keys. And the latest systems from Crypto AG are clearly leaking the keys in the cryptotext, and that enabled the US and several other secret agencies to read all the communication, for instance, from Libya, from different Asian countries. There are a lot of third world countries that are using Crypto AG stuff or have used Crypto AG stuff until that problem got public.
Gaddafi was not amused.
They were really not amused, and this was really funny. 2 years ago or 3 years ago, the Crypto AG had a big booth on the CeBIT. CeBIT is the big IT fair here in Germany. It's the biggest computer fair in the world, and they had a big booth there with a lot of stuff and high-speed line encryptors, a lot of people there. And I came there and started asking questions, and then after I came to the more interesting questions, they gave me Crypto AG issue Toblerone, the sweeties, a lot of them here, And do you want some paper? And here we have some other stuff. They gave me a whole plastic bag full of crypto AG merchandising ware, just that I go away. So that was really interesting. I told this to several other people, and they also got a lot of stuff from and the next year, that whole affair was it became public because a technician from Crypto AG was arrested, I think, in Iran, and or was it Iraq? I don't know. I just confused these two countries, and they. Because of suspicion that the Crypto AG is leaking keys, and this poor guy didn't know anything about it, and they held him for about a year or something like that. And Crypto AG did make the failure not to get this guy out there, and not to help him. So this guy got really what you call a disgruntled employee, and he started researching, and that brought everything rolling, and so it got public that the Crypto AG keys were leaking. So, and the year after that, on CeBIT, the Crypto AG had a booth that would fit here in the corner, and they had only two products there. One was a crypto-enhanced GSM telephone, and the other thing was an 34 megabit DS line encryptor for ATM, and you had only one person there on the booth, and they had no merchandising material, even if I started asking bad questions. They were completely ignorant, and I think they're practically out of business, because trust is everything in cryptography, and I became suspicious the year before then, because I asked them what algorithms do they use, and what the key lengths are, and they have some very slippy things about on their pages, how long the keys they use are, and if you ask them what algorithms they use, they say, okay, your dear customer are for us so important that we design for you a special algorithm. And then I asked the guy, you know what you're talking about, and you know what cryptography is, and you know how cryptography works, and you know how algorithms are verified. Yes, we have a lot of cryptographic experts, and we are custom designing for every our customer that buys some devices from us, and special derivative of the algorithm we use. So that is really snake oil what they are selling there, and so I think they are out of business now, nearly. And there are some Israeli companies that are selling also crypto stuff, but as usual, don't trust any Israeli high-tech more far than you can throw it, because Israel is a very small country, and everybody who's somehow smart there is getting in contact with the security establishment there, and especially the high-tech companies are under heavy influence from the security agencies there. You can surely bet that Israeli security high-tech has backdoors. So you also can buy voice encryption stuff from bigger companies like Crypto.com here in Germany, in Aachen. They're doing more the high-speed crypto stuff, like not a single-line POTS interface crypto telephone, but more if you have a T1 or a 2 megabit line or whatever, to encrypt you can go there.
Sorry, I don't have that.
Okay, and maybe you have two locations of your company, and have a VPN there, and need to connect these locations securely. You can buy the stuff from them. But what made me a little bit suspicious was that this Crypto.com is partially owned by a South African holding that was formerly very active in arms trading and in several other suspicious activities. And so, it's better to build your crypto yourselves and look at the code and look at the hardware yourself, because all this commercial stuff is somehow a little bit suspicious. Yeah. Yeah, I know they're now sold to Timaco, and this South African holding has now about 8% or whatever on this, 10% yes, on the new venture, and but I'm still suspicious, because that is I don't know who was owning Utimaco, by the way, because I don't think it's all German anymore. Belgium, okay. Huh? Okay. From okay.
Did I mention that we try to build an US import version, which reuses the key lengths in certain ways? So the US people, if they really use it as a compiler define, won't have any trouble exporting it.
Okay, so it's a 40-bit just technical security.
Yes,
version.
as a to 512 and RC4 40 bits, and that's enough.
Yeah. At least
We
for
might
friends from
also
America.
have a version which is not doing encryption at all, which is just to do voice over modem. But well, this will be an option.
That is the option for the French people then.
Just to get better phone lines, like there will be no voice on international calls.
Yeah.
Have you given it a thought to do high compression algorithms like the linear predictive codings?
Yeah, we have verified that, and I must say that this CPU has no floating point. So all these implementation we have seen that I may use for using a better codec are mostly floating point. So and they are so intensive in calculating that it really won't run on this hardware.
Because we did some experiments with Speak Freely, a PC package.
Yeah, you mean the LPC 10 codec, yeah. Mm.
We successfully had fully understandable speech, although the biometrics would be difficult.
Yeah,
It would be hard to
bit synthetic.
to understand
Mm.
to hear whether it was really the person you think it was. But the speech was still good enough at 2400 BPS, meaning that even with all
It
the
was
loss...
4.8. It was 4.8. 24 was bad.
Oh, 24 was bad, okay.
Yeah,
But anyway,
yeah.
it still worked over a GSM data stream,
Yeah.
which means you
That's
could build
true,
a version of
that's
the harmless little box.
Yeah. But
Which would then have an infrared LED, which would just talk to your GSM telephone.
if you the point is if you try to use that codec on integer only hardware, you have to redesign it and to re-implement that
I understand.
to make down these what they do. You can buy codecs that are doing this by integer, like LPC10, from companies that develop commercial codecs for DSPs or this like, but they cost a hell. And
You mean to license or every time?
the license, and mostly they charge you about $100 per license. No. LPC10 is no ITU standard, and it was developed for military systems in the USA. I think it's a DoD standard. Yeah, and the reference implementation is still floating point. The ITU reference implementation of this coding is floating point. You are not allowed to use it in any way, and they will sue you. And you have to re-implement that, and it probably will kill your brain, because this codec is, wow, it's a codec. It's just not the lousy GSM standard, and you have to do too much to get it down to this.
Yeah, LPC10 was developed on a DoD contract to have a secure two-way radio communication for the army in the field over a very small bandwidth. So they are using it on radios that have really 2.4 2.4 kilobit bandwidth on shortwave radios to have secure communication there. And so this codec is fantastic, but a little bit nasty in regarding to the
We'll see
rights.
how it works with the 120 megabit version, megahertz version. Perhaps it will do it, but I can't tell it now.
Yeah.
We might upgrade our hardware to floating point. It might be cheaper than buying a license.
Yeah, perhaps we because we are only using the SRH3 version. If you buy a Dreamcast from Sega, which is the next generation, it probably will. It's strong enough, yeah.
Okay.
But the point with GSM is that there's an option. We have IRDA, infrared data. We could connect a diode to emit such light and receive this. And by that way, you could connect with your GSM handy, which typically has this feature too. And if we are able to reduce the data rate, you could then have secure speech via GSM.
I suspect that we have faster or higher bandwidth over GSM than you're already with this hardware.
No. Perhaps for E+, but not for the DNet.
Okay.
No.
And remember, infrared is light, right? So shield,
Yes,
Shield
that light.
yes. Make a tunnel to a
No, it's
paper
encrypted. It's
from
It's
your phone.
encrypted already.
It's encrypted
It's
already.
encrypted, yeah, that's no problem.
I take that back.
Or see to it.
You also can do it serial, so.
Okay, I write down an URL to get further information. You can find all the source and the hardware design too there, and an email address if you want to get in contact.
Yes.
Yeah.
So also, I have a question.
We have to set up.
Of those persons still be here. Who's still interested in this project?
We need volunteers for the Windows software.
And who's able
Hey,
to,
come on.
So come on, who's able to
The
program
Windows
on
software
PC?
that actually talks to the box?
Huh?
The Windows
No,
software
that runs the
puts
software on a Windows PC, because you need the HLB only if you have no PC with sound card and enough CPU
Okay.
ready and a modem.
But in
You
other
can
words,
run
you-
the same software on a PC on whatever operating system.
Okay, so you're planning a set of interoperable things. You're planning
Yes.
a hardware device, a Windows implementation, a little
What we are
Right.
really doing right now is a standalone device, but to extend the capabilities,
Yes, of course.
we want Windows software. We will need this, and right now our team is just limited to develop the hardware itself. But we want to extend our team, and if there's somebody who's volunteer and is capable of programming on Windows NT, Linux, whatever, well, feel free to contact
Mac
us.
OS.
Or... Sorry?
There's no license. I sue you.
It's free.
No. You can have the source, but if you build commercial projects with it, it is not allowed.
But what if you don't use the source, but you want to be interoperable?
That's okay.
So in other words,
I have no
the protocol-
problem with that.
The protocol is open.
Yes, but it's still not designed. To take that in mind, it will take care of designing a good protocol. We have the protocol from the VP1 device, and perhaps it will be similar to that, but perhaps not. I don't know, because we have to keep more in mind not only for using it on analog or ISDN lines. We have to design it for IP networks also, not to reinvent the wheel if we ported an IP stack to the box.
So somebody is interested in joining our team of building this device and all this software, please contact us. We want you. Okay. Any more questions?
What are the processing requirements for for key exchange?
Not much.
The company I work for built an ISDN telephone, and they canceled an ISDN telephone and the prices for that. But we still have to design, and I designed an RC4 1024-bit encryption
Mm.
So if you have this different element and
Mm.
the source of randomness,
Mm. Yeah, yeah. It's no problem because I'm utilizing the normal GNU multi-position library that can be downloaded from the net everywhere, and the code for implementing Diffie-Hellman with this library is it will fit onto this because it's very small. You only have to read applied cryptography and then hey, let's do it. Just implementing it will take you 2 hours if you use this library. If you have to make your own big num library, then you will have to do more.
The answer for implementation is an assembly, and it's for the AC31 microcontroller. So I have a problem there.
Mm-hmm. But can you port libraries from the GNU people to your telephone?
I mean, the compiler we're using Telephony is the compiler, so you have a problem calling GNU code.
That's very difficult. But I found a short C code on the net that's doing Diffie-Hellman in only 10 lines. But it's not. I think it was from a C contest because the 10 lines are full of information. So you have to bring it down into a beautifier. But this code is very slow on a normal machine, but it implements everything you need.
Very slow means what in terms of seconds on a slow processor?
On my machine, 10 seconds, but this was calculating for a Pentium 350 megahertz. So I really can't recommend that code. Perhaps if you see that, which is just pure C, and you say, hey, that's a nifty little thing, I port in it in assembler, it will run faster. But I can't say that.
We also had earlier the idea in relation to ISDN phone to have instead connected a modem on the top line, like we can have connected a handy maybe in the future with GSM, also to connect or to have an interface to ISDN telephone, which means we would just get the stream of the AD over there and just encrypt the digital data like we use 2 serial ports right now and give it to the line once again. But we skipped that design because, well, there's too much telephones out right now, and we will not write the D-channel protocol and support it. We will not get FCC and so on. This is the point why we skipped this. Also, external ISDN modems are available, so you can do it over ISDN, or you can use an AB box, which will make an analog line out of your ISDN.
I mean, I have the encryption working. It's just that I can't exchange keys. I mean, now I have pocket keys and that, and I take passive and communicate.
Yeah, sure. If you have it digital already, like you have in the ISDN phone design, it's easy to add encryption. Just a question of which level. The encryption itself does not take that much calculating power. What takes the calculating power, like how many percent right now from the calculating power? We are using for the 50%.
50.
We are using
and
for
that's
the
the old design,
compression
the 80 megahertz design.
of the voice to get it over a regular phone line, which is using a modem. So tunneling. We are voice tunneling encrypted voice over modem.
I hate that.
Okay, some more questions? Yes.
Is there any way to protect which kind of encryption you're using without even having the, by the way, you commercialize something, if it's known, even if the source is known or not, but is it possible to detect which kind of encryption you're using if you're talking about random or something?
How if you're using the device, if you press a button to get encrypted, or if you get a device which encryption is built in? What do you mean?
Yes. Yes, of course they can detect what kind of encryption you are using, because you have to handle that in an open session.
Also, like
That is always true, because otherwise you have to say that this device is always using this and this type of encryption. So you have to exchange the type of encryption, the bits that are used in an open session. So they will probably know about, but probably know, okay, it's wasteless, it's a waste of time, because he is using a 4 kilobit bit key for doing the calculations on the public key system.
But in the case of the first conversation you're having with that person on the phone, I mean, you have to trust it by the way you said, by hash key, but if they know which kind of encryption you're using, and then you can use the hash key, then is it really effective?
Yeah, perhaps you can say we won't exchange it automatically and we will set up it manually.
Also, well, we will have an option, like if it is the second conversation, we can still have a hash key of the old conversation to know if it is the same person we have talked already on the cryptophone. But on the other side, it is, this is a problem of key exchanging on the first time. But this is a general problem which you will have in any encryption software, PGP and so on. How do you know the other person on the other side is the person he is saying he is? This is on PGP. If you did not talk, if you did not meet a person, how do you know what person that is? Not just on encryption on the phone. If you know that person, you can just exchange a piece of paper with some first hash keys.
Yeah.
This is secure,
Yeah.
and this works also on PGP and so on. Sorry, I didn't get the point. Can you just take the microphone and try to explain? It's just on the other side.
I just said that if is it really possible today to commercialize any encryption system without leaving any leaks? Because I mean now you have good. I don't doubt you want to do something.
What Frank told you, it is possible, but if they know you are doing it, you will make no big income afterwards.
But to go to commercialize something, you have to go through a lot of steps. So during those steps, you think you're going to go through without leaving leaks.
Yeah, but if the point is if you
also on a commercial project, later you can view the source and verify that it is the same which is published. Like you're not just getting the device with the ROM and so on, but you can also hash the ROM and verify it and reflash it or whatever you want to verify that you have the software. You can exchange the firmware with the firmware available and which is publicly discussed. This is an open source project. If you want to discuss the encryption, it will get discussed.
You only have to build the hardware. The software you can compile on your own.
And you can verify and you can get it from the person you trust if it is not tampered, or verify it yourself. Okay. Next question. No questions.
No. Okay. Thank you all.